Hello folks, welcome to another exciting Lexus hybrid gearbox video. Probably not going to be making a whole lot of sense this evening. My head's melted. It's been a crazy week, but I just came out to the workshop this evening just to try out some new hardware that turned up today. So one of the big challenges of driving an internal permanent magnet motor is dealing with something called the resolver. Now, the resolver is a method of telling the controller the exact angular position of the rotor. So if we were to take straight up here, for example, as being 0 degrees, we then have a whole 360 degrees to go through. But a resolver is an extremely accurate way of determining the exact position of rotation of our rotor. And for an internal permanent magnet motor, that's very important. Now, when one does a search and looks at resolver circuits, there's not a lot available. There's a lot of very complicated looking circuits going on out there. So, but there are devices called resolver to digital converters, and some of the ones that I've observed are manufactured by analog devices. So I did some research and I settled upon the AD2S 1205 resolver to digital converter chip. And this particular guy has a lot of features on it, but guess what? We're going to try to not use them. We need some of the more basic features. Part of what this device does is it does what they call encoder emulation. So it does all the reading the cosine and the sine signals and driving the exciter winding in the resolver, and does all the signal processing. It has serial and parallel interfaces, as I say, to communicate back to a microprocessor to tell it in digital format the exact position. But the encoder emulation gives us two 5-volt square waves, A and B, the exact same as a normal quadrature encoder on an induction motor might give us. But it gives us one other signal, which is extremely important for what we're going to be trying to do here with the inverter. There's a signal called NM, which is north marker. And this signal fires once per revolution when the exact angular position of the rotor is straight up north 0 degrees. And this tells us an important piece of information that's going to be hopefully rather critical to our inverter being able to drive this particular motor. So I'm going to bring you guys in close, let you have a look at the little evaluation board here that I got from Analog Devices, and I'll show you the north marker signal firing on the oscilloscope. And that's it. So really exciting video, but I just thought I would share it with you guys, because it's my first dive into this whole internal permanent magnet motor, resolvers, resolver to digital converters, and so on. So let's not waste any time and get straight in here. Okay, welcome to the AD2S 1205 resolver to digital converter PCB. This is an evaluation board which has a lot of features on it that we're not going to use. So when we ultimately design our own version of this, it'll be very much cut down. But it lets me very, very quickly see if I can interface to the resolver in the Lexus transmission, and indeed, you know, if it's compatible. So you'll see some LEDs here. You'll see this green LED marked A is currently illuminated. That's the A channel from our. In fact, let me turn off some light here. It might be a little bit more apparent. There we go. That's a little bit better. So there's our A channel is now high. Our B channel, which is beside it, is low, and our north marker is currently off as well. So if I rotate the shaft, we'll see a few things happen here. So I'm just spinning the shaft by hand. If I slow it down a little bit, just so hopefully you guys might see the LEDs flicker. It's 1024 pulses per revolution, so it's going to be very quick. So these are our two encoder emulation channels. This is DIR for direction. We also get a digital high when we turn in a clockwise direction, and a digital low when we turn in counterclockwise. Now you might be saying to me, Damien, I'm not seeing the north marker signal firing. And you're not seeing the LED because it's an extremely fast signal, as you may expect. So let's have a look on the oscilloscope, and we'll be able to see it, hopefully. Okay, so bundles of excitement to follow. This is just a freeze frame of the north marker that we were just doing prior to shooting the video. We can see the pulse. It's just a normal 5-volt square wave, and I can put my markers on there. I'm getting a duration of 94 microseconds, so it's rather fast. So let me see if I can catch that for you guys again. I'm going to go in on north marker there now and go for some spinning. There it goes. So you can see the pulse is kind of firing there as I'm spinning the gearbox over by hand. So if I were to go on to one of the A or B channels, you'll see they'll be a lot clearer. If we go into channel A, you can see that there's a lot more pulses. That's our encoder emulation channel A. Channel B. And finally back to our north marker. Firing away merrily. So, there we go. Analog devices, resolver to digital converter. Great fun for all the family. So, quick video just to show you guys that. Thanks a lot for watching, and we'll be back soon, hopefully with some more motor control madness. Stay with us.